Okay, we are on. We're rocking and rolling. Okay, so today we're going to, first, I want to talk about the several quizzes, or the evolution of the periodic table, right? What I want to do is, the first quiz is going to be, you're going to have to draw a blank periodic table. Periodic table from now on will be generally known as PT. Okay? Just PT. You have to draw a blank periodic table. Okay? Understood? Yes? With, the 7 rows and the blank spaces and periodic table. Understood? So you have 118 little squares put together in a certain way. Yes? Okay. And then the next one, I'm going to give you, given a blank PT, right? I want you to number it. Number table 1 through 118. Okay? Understood? Yes? Okay. The next one is given blank table, place, symbols you need to know in proper location. Clear? Yes? You all right with that? Then we're going to continue. Simple stuff. Then again, given blank table. GBT means given blank table, okay? GBT, you want to place known charges. Above columns. Understood? Yes? Okay. What else? So let's say that's enough for now. Understood? Those 4. Okay? Just simple tables. Okay? And you'll have simply blank tables. So you gotta really know how to deal with a blank table. Okay? Oh, my shoulder.
That's my work.
I know. All right, so ask me anything you want. The way we're going to run class today is you're going to ask me anything you like. Understood? All right, so give it to me. What do you want to know? You have the chapter. Come on, let's go.
Are all chemicals liquids? What is your...
Our question, are all chemicals liquids? All right. There are several states of matter. Okay? There's solid, there's liquid, there's gas. Okay? Now, the chemicals are either solid, liquids, or gas. We're not going to talk about actually the dominant type of state of matter, which is plasma. Right? A star is in the plasma state. Plasma is essentially a soup of charged particles that are so energetic that there's no positive, negative attraction. You've seen a match. Anybody have any matches? A lighter, anything? You have a lighter with you now? Anybody? That flame, that weird thing. It's not a solid. It kind of doesn't look like a gas even. It's something weird. Yeah? And it is completely different. It's not a solid, it's not a liquid, it's not a gas. It's a plasma. That flame is so hot that the particles in the flame are simply in the plasma state. There's no positive or negative. There's charged particles, but there's no attraction. Positive, negative, but they're not attracted to one another. Okay? Plasma. So what is it?
Type of metal, right?
Type of metal?
Yeah.
No. A plasma is probably the closest thing to a plasma is a gas. You know, it's not a solid.
No, the thing you're telling about like max one?
No. When you light a match and you have the flame, I'm talking about the flame. Okay? Now, if you're going from solid to a liquid, what's that called? Solid to a liquid.
Melting.
Melting. Right? If you're going from a liquid to a gas, what's that called? What's it called? Evaporation. Okay, good. If you're going from a liquid to a solid, what's that called? What's it called? Freezing.
Sir, can you not use boiling instead of evaporation?
I'm going to talk about boiling in a second. All right? If you're going from gas to a liquid, it's what? It's called condensation. Okay? It's called condensation. You have to know this. Isn't this in the chapter? Can I have some? I know this is first period, and you guys are half asleep, but can I have a little help here, please? All right. So if I'm going to go straight from a solid to a gas, what's that called? What's that called? Sublimation. Very good. It's called sublimation. Sublimation. And what's it called when you go from a gas, the reverse, what do you call it? What's it called? What's it called? I can't hear, what?
Solidification.
Called
Solidification.
Deposition.
deposition. Okay? Deposition.
Deposition.
So these are really physical changes. Yes? These are physical changes. These are physical changes. Now, somebody mentioned, well, what about boiling? Can evaporation be boiling? Well, boiling is a specific phenomena where, I'll give you the short version, and I think I may have even said this. If you take a 1 cubic meter of water, that's 1 metric ton, it's 2,200 pounds, it's 1,000 kilograms. It's very heavy. And if you're under that, will squash you. You would die, okay? If you take 10 of those and put them on top of each other, that's 10 tons, okay? That's what the atmosphere is. But we're used to it. We're built, we're constructed in an amazing way to withstand 10 tons of air on us. It's unbelievable, really, the pressures. So, when water boils, Alvin, you're the one that asked this. When water boils, it's going to give off gas. Yes? That's going to create pressure. Yeah? That gas that evaporates is called vapor pressure. Does that make sense? It's called vapor pressure. When that vapor pressure, this is the atmospheric pressure, right? Let's get rid of this word plasma. You have atmospheric pressure, correct? Yes? Atmospheric pressure is coming down. Vapor pressure is going up. When the vapor pressure equals the atmospheric pressure, right? When the vapor pressure equals the atmospheric pressure, the gas, the liquid can go right into the gaseous phase. There's nothing preventing it. What happens is the atmosphere is preventing the bubbles to form. You get it? It's preventing it. The atmosphere is so heavy The water wants to bubble away, but it won't. It's being held in the liquid state. Yeah? When the atmospheric pressure, when the vapor pressure is equal to the atmospheric pressure, it's strong enough to break apart dramatically and form that bubble. If you lower the atmospheric pressure in a jar, let's say we have an apparatus, a glass apparatus, and in that apparatus we can put a beaker, okay? And we can fill it with water in the beaker, okay? Yes? And we'll take away the atmosphere inside that big apparatus. The water will boil at room temperature because there's no pressure holding the water in the liquid state when it warms. But it's the atmosphere that holds the liquid in the liquid state. Now, when things evaporate just from the surface. Okay? It's just from the surface. Individual water molecules will become energetic enough to escape the water phase. Yes. You have a question? Okay. Yes. Yes, Nabil.
Resistance of solid.
Excuse me?
What does resistance of solid mean?
I can't understand.
Resistance of solid.
Resistance of solid. What's that mean? Where's that?
Sir, you didn't answer my question. Are chemicals on liquids?
Where's that?
The hardness is a measure of
Can I see the text? Where does it say? Oh, hardness. Hardness? Yeah, hardness is a physical property. Is it still taping? Hardness is a physical property, and if I have two things, if I have two materials, yes. Let's say this is diamond and this is a hard rock. Diamond is harder, and I go like that. The diamond will scratch the rock. Okay.
because diamond is more hard.
Yeah. If this is hard, but this is harder, and I go like this, it won't make a mark. You know, I can go like that. It won't leave. So hard scratches softer. So all materials, all solids, not liquids. Solids have an inherent quality of hardness. It's a way to identify it. If we think something is diamond, yet a diamond scratches it, is it diamond? No, it can't be. Yeah. So yes, those are properties. Okay, it's a property of that matter. Now, there's two kinds of properties. Where's the eraser? What did I do with it? Did I put it in my pocket?
This one?
Yeah, but I'll use this one for that. There's two kinds of physical properties, guys. And they're both going to be on the test. They don't mention this in the book, but I'm mentioning it here, so you have to know it. Understood? Yes? It's called extensive and intensive. These are extensive and intensive physical properties. Okay? Physical properties. Yes? Extensive physical properties are just based on the quantity of matter. This is quantity. The quantity of matter. If I take a piece of paper, this piece of paper has a certain mass. You see it's torn here. Has a certain mass, right? Okay? If I take half of it, I've changed the physical property of this paper. I've changed the mass, right? It has a different property now, doesn't it? Yes? I have a certain length here. Now I have a different length, yeah? Now, does the mass of this paper, can I use that to identify this as paper? I can.
Yes.
Somebody tells me I have something that weighs 0.1 grams. but I don't see it. Oh, that's paper. Everything that weighs 0.1 grams is paper. Does that make any sense to you whatsoever? No. So, can mass be used to identify a substance? It can, Adib? Are you even listening? No, you're not. Can mass be used to identify a substance?
No.
It can be? You know what you're saying, even saying yes to? Is it too early in the morning? These are two different caps. They may well be two different plastics, right? Yes? They weigh exactly the same mass. Do all caps of this material have the same mass? Do they? Of course not. Can I use mass to identify a substance?
No.
Listen carefully to my question. Is mass characteristic of an individual substance?
Yes.
It is? Do you even know what you're saying yes to?
No.
Sir, the mass number of an atom.
No. You guys are half asleep. I'm asking you. I weigh 200 pounds. Okay? I weigh 100 kilograms. I weigh about 220 pounds. I weigh 100 kilograms. Okay? Now. Am I the only person in the world that weighs 100 kilograms? So somebody says, you say, I have a teacher, they weigh, you go to America to go to school, and somebody says, oh, my teacher said today in class, it was really weird. He said that they weigh 100 kilograms. Oh, that's Mr. Darcy. It is. Because when I lived in Bangladesh, he said he weighed 100 kilograms, so they're the same. Everybody who weighs 100 kilograms, that's Mr. Darcy, he's the only person in the world. I can identify him simply by his mass. That's what you're saying. My half-asleep class. Romana? Yes, Romina? I call you Romana. I want to call you Romana. Changing your name. Okay? So can I use mass? Can I? Are you awake now? A little better? Yes? No? Alright, so it's based on the quantity of matter. So mass. Do you guys realize that I'm like right here?
Yes, sir.
Are you sure? And that I'm filming here and you're having this little conversation over here? Do you have any idea how disturbing that is? No. No, of course not. Okay, so mass, length. What else? Volume. Can they be used to identify material? I'm telling you, he's like a horse. He's a horse that's slow. One of my parade horses. He's washing his face in the sink. I like that. I'm telling you, the parade horses, they have no idea what they're doing. They have no idea their manners stink. Okay, so now, let's talk about this. I have an unknown substance I left at home. And I'm going to give you some data, and you're going to tell me what it is, okay? I'm going to give you intensive physical properties. It's clear, it's colorless, it's odorless, it has a boiling point of 100 degrees Celsius, it has a melting point of 0 degrees Celsius, okay? It has a specific heat capacity, we'll explain what that means, of 4.18 joules per gram degrees Celsius. It has a density, of 1,000 kilograms per 1 cubic meter, or in chemistry we say 1 gram per cubic centimeter. That's a rho, that's a Greek letter rho, means density. Density can also be D or a rho. Okay? What else? Excuse me?
Isn't that the freezing point?
Boiling point, melting point. You know, you don't really say freezing point unless you're talking about colligative properties. Long story. It's usually in literature since it's MP, melting point, but it's the same point. But we'll learn more about that later. So, oh, I know. No, that's it. So what do you think it is?
Water.
It's water. Here's another one. Here, I'll give you another one. It's
H2.
non-flammable.
H2. Has to.
Yes, yes. It cannot. These are intensive physical properties. The literature, meaning what's in print. You know, research. They say literature. You know, if you go to the literature, they say intensive physical properties, or they say characteristic. Characteristic physical properties, one or the other. Okay? Now, Alvin, you had a question. Can you ask me that again? You said I didn't answer?
Are all chemicals liquids?
Are all chemicals liquids? Well, what I was trying to get at, the question is, are all chemicals liquids? Well, at one temperature or another, they could be. But at room temperature, let's pick a temperature. Room temperature, is that okay? No, they're not all liquids. Is gold a liquid at room temperature?
Gold is a chemical.
All right. That's a good question. Okay, that's a good question. Okay, I'm going to put this on pause, erase the board, reset, and we'll answer that question. It's a great question. Okay, all right.
I'll erase them.